Hello, everyone. Welcome to the Water Research Foundation webcast on Project 5321, the role of generative AI for the global water sector. This is a partnership project between the Water Research Foundation, American Water Works Association, the Water Environment Federation, and is being led by Karmous Edwards Consulting. We have a fantastic webcast for you today, and I'm excited for us to get into it. Thank you all for joining us. My name is Sydney Samples. I'm a research manager at the Water Research Foundation, and I'm going to be moderating today's webcast. So, as I said, we've got 5 fantastic speakers today. First, we'll hear from Fidan Karimova, Senior Director of Circular Water Economy at WEF. Then we'll hear from David Hale, an engineer at AWWA. Next, we'll hear from Gigi Karmous Edwards, the CEO and President of Karmous Edwards Consulting. And then we've got 2 utility case studies that are going to be led by Robert Bornhofen, the Director of Innovation at DC Water, and Jeff Sparks, the Director of Digital Water at HRSD. Before we get to all of the exciting bits, I do have a bit of housekeeping to go over. So first, throughout the session, you can type your questions in the box in the presentation or below the presentation on your screen. We'll answer as many questions as possible in today's presentation. And if we don't get to them, we'll follow up with you after the session. Slides and a recording of the webcast will be available on WERF's main website. You can download the slides now and also access a link to the project page on the bottom left of your screen. Our certificate of completion will automatically be generated after the webcast. Any questions about this, please email Michelle Suazo at msuazo@waterrf.org. Lastly, please stay with us until the very end to take a quick survey. We use this to improve our webcasts and make sure we're providing the best content to you all. So with that, I'd like to pass the floor to Fidan to kick us off.
Thank you, Sydney. Good afternoon, everyone. I'm thrilled to represent the Water Environment Federation. At WEF, our mission is to inspire the water community in pursuit of human and environmental well-being. Our strategic goal is centered around building a diverse and passionate workforce, cultivating a purpose-driven community, as well as leading the transformation towards a circular water economy. Data-driven innovation is at the core of these efforts, especially as we look at accelerating progress on circularity. That's why this project is so important to us. We're excited to be part of this research initiative along with WERF and AWWA. The project represents a significant step in understanding how generative AI can transform utility operations, management, as well as long-term sustainability. WEF is committed to proactively shaping the responsible adoption of AI in the water sector, and we see this collaboration as a key opportunity to drive meaningful innovation for the broader water community. And with that, I'll pass it off to the next speaker.
Thank you, Fidan. Hello, everyone. My name is David Hale. I'm a program manager at American Water Works Association and the principal investigator on this project. Today, I'll be giving a brief overview of the project and some of its goals. Here's what I'll be covering today. First, I'll be introducing the project leads who are instrumental in driving the project forward, the key objectives for this project. Following that, I'll be taking a look at the current timeline, and finally, I'll touch on how AWWA is aligned with this project. So these are the project leads. Sydney Samples from WRF is the project manager and leads the project advisory committee in reviewing and guiding this project. There's myself. Gigi Karmous Edwards from Karmous Edwards Consulting is our co-PI and GenAI expert leading the research. And you just heard from Fidan from WEF, a co-PI who brings the circular water economy perspective. This collaboration has helped leverage diverse backgrounds and insights throughout the course of this project. So here's the overview of the project objectives. The first objective focuses on establishing a foundational understanding of generative AI's role in municipal water and wastewater utilities and cultivating a common vocabulary that we can use across the water sector. The next objective is to develop guidelines and best practices for utilizing GenAI and large language models effectively. Additionally, we have been developing case studies to show real-world applications that have been developed by water utilities around the globe, a few of which you'll hear from today. And the last objective shown is to develop a research roadmap to steer future initiatives within the water sector. All these objectives could not be completed without the diverse and technical expertise from our global generative AI utility group, or G3 for short. This group brings unique experts and experiences from utilities around the world. So this is our current timeline. It provides a roadmap for our project activities. It began with the G3 group meeting this past December, which kicked off a reoccurring monthly meeting with this group, which leads up to our first workshop that'll be held this May. And then these meetings will continue on until our second workshop later this year. And then finally, we'll have a final deliverables due in November. This structured approach ensures that we maintain momentum and stay on course. And lastly, I wanted to briefly touch on AWWA's alignment with this project and how it connects with our vision of a water utility and how it looks like in 2050. For those of you who don't know, Water 2050 is an initiative to establish a long-term vision for the future of water. This initiative fosters partnerships and cross-sector collaboration that extend beyond our industry to benefit the global community. AWWA's involvement with this project shows our commitment to innovation in the water sector. This quote from David LaFrance, the CEO of AWWA, underscores the importance of integrating cutting-edge technologies like GenAI. Our goal is to develop best practices that will guide the water community in leveraging these advancements effectively, ensuring we are prepared for the future. So as I hand it off to Gigi, I just want to express my gratitude for your participation. If you have any questions or comments, please feel free to contact me with the email address that was provided. And take it away, Gigi.
Great. Thank you so much, David. So, yes, happy to be here and very excited to share with you what I'm going to be talking about. So I'm going to first talk about just level setting definitions at a very high level. I'm going to talk a little bit about the power of unstructured data, which is really what these large language models give us. And then what are some of the capabilities, give you a few examples, and then talk a little bit about this research project. So first, just to level set, and again, this is at a very high level, AI has been around since the late 1940s. It is really a broad field of computer science that looks at computers behaving similar to humans and doing human-like tasks. There is a subset of AI called machine learning, which is it learns from data and identifies certain patterns, and based on those patterns, using algorithms to identify the patterns, and then based on those patterns, be able to predict future data. Deep learning is yet another subset of machine learning, and it uses something called neural networks, which actually comes from the idea of our brains. We have neurons in our brain, and we use neural networks as layers of patterns so that we have algorithms that can detect the complex patterns. And then from that identification of patterns, we can predict future complex patterns. And then we have something called natural language processing. This is the ability for the machines to understand human language and translate that. That's a very important concept that then is used in generative AI. And what distinguishes generative AI from the other subsets of AI is that for the first time, it can create new content, either new images or visuals or new voice or new text. And that's one of the distinguishing factors of generative AI. We understand it uses something called a large language model. The reason why it's called large is because it really trained on almost the entirety of the internet, including textbooks and law documents, all kinds of information and YouTube videos in order to be able to produce new content. So this is just a very high level understanding of how all of these things fit together. And what this project really focuses on is generative AI. This is a diagram that kind of gives you an idea of what's been happening over the last 3 or 4 years, 2 or 3 years, basically, since the initial ChatGPT. I think that was in November of 2022. And we are seeing progress almost on a weekly basis across all the major players in producing these large language models. And one way we can kind of understand what our progress has been or where we're going is by looking at different benchmarks. Human intelligence is a very difficult thing to, it's very subjective. So instead of using that as a way to understand how we've progressed, there is a benchmark called GPQA, Graduate Level Google Proof Question and Answer Benchmark. And just to give you an idea of like when first ChatGPT came out, that GPQA number was at 28.1%. And if we take a human that has studied and gotten a PhD in a very specific domain, we would look at that question and answer using Google at a 65%. And then if we start to look at what's happened since then, like for example, DeepSeek R1 came out at 71.5%, which surpasses what we would consider the highest level of human intelligence with this benchmark. O1 from OpenAI came out at 78.3. And now I don't know if any of you have been using O3, which is amazing. It's at 87.7%. This is just a relative way to see the progress over the last 3 years with these large language models. Now, definitely there are lots of barriers and risks and downsides with these large language models. But the purpose of this research project is to see how water utilities in particular can leverage their capabilities. So looking at some of these risks, a lot of utilities would say, well, you know, why would we get involved with generative AI? It can one day take over our jobs, or we might have job losses due to that. I believe that this is not a problem in the near future because right now, most utilities are having a hard time hiring new employees. And we don't see generative AI capabilities as competing with a human being. We see it more as an assistant to a human being or a co-pilot to a human being. So it takes every role within a water utility and enhances it, hopefully saves time and increases efficiency. The other big area that people worry about are hallucinations. And definitely these large language models are very capable of hallucinations. And just to level set the definition of what I mean when I say hallucination, it's when the large language model gives you an answer to a question very confidently as if it's true, but in reality, it's not true. And that's what we're calling a hallucination. So what's important here is that when you do work with these large language models, you need to ask for verification and validation. So if it gives you an answer to something, you can easily ask you to give you a link of where the source was that this answer came from, so that you can validate the answer and make sure that you trust the information that it's giving you. So hallucinations are important, but I can tell you that over the course of the last 2 or 3 years, hallucination have reduced tremendously, but there's still a problem, and so you always have to verify. The other area that we worry about is, water utilities are a critical infrastructure, so cybersecurity is of the utmost importance, as well as data privacy, because we are dealing with citizens and information about citizens, as well as the infrastructure of these utilities. So the way we get around that is we use an enterprise level large language model. With OpenAI, you can use something like Team version, which is about $25 per user per month, but the capabilities that you get for that are enormous. Once you get a enterprise level, it's important for data protection to go and toggle the sharing of data for training so that none of the data that you upload as a water utility gets shared. And so that's how we deal with some of these barriers and downside. I'm going to go to the next slide. So now one of the clear, the importance of these large language model is really the power of unstructured data. So let's talk a little bit about what is structured data versus unstructured. We are all used to using structured data such as sensor data or SCADA data or even weather data for our data analytics to provide us insights for data-driven decision-making. Now imagine having access to unstructured data for that same data analysis. Unstructured data is about 80% of any enterprise. It includes things like images, audio, videos, PDF files, Excel spreadsheet, anything you can imagine that, well, Excel spreadsheets is usually more of the structured data, but anything that you can imagine outside of structured data is unstructured data. And now with the ability for these large language models to understand language and to understand images, that unstructured data can now go into your data analytics for data insights, for data-driven decisions, and later on, once the trust has been built, maybe some level of automation. So another important concept with these large language models is called RAG, Retrieval Augmented Generation. I'm sure many of you have heard this term before. What it does is it takes your data that you upload and uses that for the query response with these large language models. This is a really very powerful tool. And what it does is it takes your data such as images or PDF files or, even handwritten notes, videos, voice calls, and turns those into vector embeddings, which is really numerical translation of this content into something that the large language model can easily access and understand. So it keeps the context and the meaning in these vector embeddings and allows the large language model to help you with a query and answer. This is sort of like the low-hanging fruit of the capabilities of these large language models because it quickly can allow you to upload all types of diverse sets of information and have a query answer system that is very focused on your environment and your data. This is a very powerful tool, and we've used it in the experiments with this research project quite a bit. So how can the water sector really harness the power of generative AI? Well, before I get into that, I want to just talk about an example from the medical industry that I read this interesting article talking about breast cancer and the access to large language models, computer vision. And by using its computer vision, doctors were able to detect breast cancer about 5 years prior to what a human doctor could see. And this, by using this, is going to save quite a bit of lives. The reason why I wanted to share this is because you can start to translate that or extrapolate this example into what we can do in the water sector. And imagine with photographs of algae blooms or microorganisms in sludge. There's so many ways we can use computer vision capability. So just to talk about a few of the capabilities, one is, digitizing hard copy information. One of the experiments we ran was with a small utility, excuse me, that collects a lot of data, about 100 data points a day, where they handwrite it in this sheet of paper. And then later at the end of the month, they do the data entry so they can generate the reports necessary. Here is another example where we can take a photograph of those sheets that are handwritten, use the OCR capability and turn it into an Excel spreadsheet for further data analysis, and very quickly as well. So using that digitization of hard copy information is important. You could do that with diagrams as well and turn that into something that's even more useful. Automating data collection. Today we mostly type in some of the data or we handwrite notes and we turn those in. Here we can start thinking of other ways through video or voice to take in some of the data as input. Let's go to the next slide. And again, I think we can leverage a lot of the capabilities like OCR, computer vision, voice recognition, all of this to help with the digital transformation and the acceleration of digital transformation, no matter where you are in your digital transformation journey. You can also imagine it being used for helping with training and actually personalized training to an individual based on the back and forth between query and answers between this, the training facility. Another example, so one of the things that we are doing in this research project is also looking at creating GPTs. This is the capability in OpenAI to, write little chatbots that are very specific. Here's one that I wrote several months ago where you take a photograph of a sludge sample and, you take that entire photograph, you upload it, and it can help identify all the microorganisms. And I haven't done this yet, but eventually you can get it so that if you put in, like I put 4 drops onto the slide, you can get a volume and it can approximate the concentrations of the different microorganisms, which will then lead to this chatbot giving you recommendations on how to optimize that biochemical reaction, either increasing aeration or increasing temperatures, things like that, to further optimize any particular microorganism. So with that, I want to introduce Robert Bornhofen from DC Water. Go ahead, Robert.
Thank you, Gigi. So, welcome. It's great to be here. As you can tell from my slide here, it's, I think, the most daunting challenge to generative AI adoption isn't the technology. Yes, it's changing quickly. It's difficult to keep up with all the new advancements and new features. It's just amazing. But it's not the technology as much as it's the people. Most people are confused. They're not really sure what it is. They read things on the internet, on Facebook about robots taking over, the end of the world, all that stuff. Some people are using it maybe on their own personal device. They might be using it at work and we're not aware of it. They might be using it the wrong way. But it's people. And to be successful in adopting this type of amazing technology, you cannot forget about the people. March 14th, 2023 is when GPT-4 came out. That was the turning point, the tipping point for me at DC Water to bring this in, to bring it home. And for the last 2 years, I've been working with the people and the leadership, but people, to be able to promote that. And that's my presentation is all about, is the people. So let's see, next slide. Here we go. So just a little bit about DC Water, not much, just so you know what it is and where I come from. Yes, we do water and sewer collection and wastewater treatment. But I think what's unique about us is the pictures on the left, okay? We have very important customers, okay? Not only government customers and military customers, but 20 million tourists, about 700,000 water customers, and about 2 million wastewater treatment customers. So we need to be very careful and get it right. And we do a great job at being able to provide these services to DC. But that's the context of what we're doing here for a large visible utility, such as DC Water. All right, so my presentation is going to be structured on where do we start, how do we do it, where do we go? Again, it's about people, right? And we're going to start first with setting expectations. No one really knows what it is consistently. And so I sat down a couple of weeks ago at the breakfast table and just started jotting down what GenAI, what it is and what it is not. And I'm not going to go through all of these. You can read that. You can see it faster than I can go through it. But it's not right side column. It's not simple to adopt. Okay, it's not a slam dunk. It's not a job killer. Yes, it does automate some routines. That's called progress. Okay. That's freeing people up from mundane tasks to do other tasks. It's about career planning. It's not a decision maker, okay? It's just an amazingly strong, impressive tool for us to use. On the left, that's exactly what it is. It's an amazingly powerful tool. Yes, it does disrupt how work gets done, but it gets done more efficiently, more effectively. Gigi mentioned the imagery, and be able to do things that we can't do today as quickly. So it's just amazing. It's really changing the playing field here for us. But again, setting expectations with your people in terms of what it is and what it's not is step one, a very important step. And then also, it needs to be put into the context of what matters in your organization. We just don't do this for the sake of doing it because everyone else is doing generative AI. We do it because it matters. Okay, it ties into our strategy. It helps us become more reliable. Okay, more sustainable, more resilient, safer. It has to have that bearing. It needs to be purposeful, ethical, free from bias, responsible, keeping us out of harm's way and our customers, trust building, and also helping us mitigate risk. Okay, so it needs to fit within a purpose for the organization. It needs to be relevant. Okay, to be able to stick and be able to get leadership to buy into it. So this is the DC water story 2 years ago, but since then it's been a lot of work. This is not a slam dunk. I've worked with working with a couple of business partners from the outside. I formed a community of practice for AI, about 80, just under 90 members across the organization. This is not top down. This is really working across laterally and then up and down the organization. We just finished phase 1 of co-pilot training. 3 months of training. We got another 4 months of training about to start off. It's imperative that your employees, with all this change, that they get trained in it so they feel comfortable with it and they know what it can do. So we're starting to build this out across the organization. You can see that what we've done with some of the C-level stakeholders who are behind this, dealing with security, make sure it's secure. And we do have risk, but we are taking steps to mitigate that risk. Okay? I don't want to make this sound like a Pollyanna type move. You have to look at the risk as well and take steps to make it acceptable. And that's getting the buy-in here. Okay, together with those on this slide, these stakeholders, we've been able to address our concerns around privacy, our concerns to make sure this adds value. The impact, there is impact that moves the needle, that we can comply with our security standards, not be too exposed to outside risk, and where we are exposed to mitigate that with controls, training, audit, and investment. Okay, these are all things that have to go on here. Moving on here, it's so important to be able to communicate across the organization. Okay, that there's a program underway. There are employees volunteering, getting trained, getting subscriptions, using the tool. It's important that these employees are giving testimonies, telling others what they're doing, and that's our second phase of training. Now that we've taught them how to use Microsoft for Excel, Word, PowerPoint, Teams, and so on, they're not going to come back and describe their use cases to their peers, their work peers. This is how it sticks. This is how it begins to scale across the organization. But again, these are all tips. You can see the top entry here that was recent, but every 6 weeks or so we communicate progress. It's real, it's tangible, and it's happening at our organization. Impact. Okay, we also have to show the impact it's making. Okay, very important to convince leadership, decision makers, to be able to sustain the investment in this type of technology and training. These are some of the prototypes we have underway. Gigi mentioned chatbots, GPTs. We've got a text chatbot being used for procurement for both internal and also our outside partners who ask questions about our procurement policy. They now can go right to our chatbot and ask those questions and get responses. Okay, it's the RAG model that Gigi had described to you. We have some ambitious plans with our customer care, from going from text to a voice chatbot, questions and answers through an avatar. Okay, we really want to take the load off of a lot of our people who are answering phones, to be able to have a lot of those questions being answered through this technology. And again, we continue to expand the awareness across the organization, okay, in terms of what this technology does, what it can do, and how you can get involved. And then one of my favorite slides is, people go from uncertainty, fear, apprehension to getting involved with an open mind, okay, getting trained, using it, maybe volunteering for a project. But at the end, we have to recognize, and we have to recognize those individuals, put them on a pedestal, and celebrate the accomplishments. I think that really gets to the underlying culture of our organization, to be able to know how to adopt a new technology, to go through change management, to be able to listen and support the employees, make an impact, and deliver on the promise. And that's my final. I think I'm at around my time here, but again, I want to focus on one thing. It's not the technology as much as it's the people, the willingness to be open to it, open-minded to it, okay, volunteer, and ultimately embrace it and use it in varying degrees. So with that, I'm going to hand this over to Jeff. And Jeff, it's all yours now. You can, there you are. Okay. Thanks, everyone.
Thanks, Robert. Good afternoon, everyone. My name is Jeff Sparks. I'm the Director of Digital Water at HRSD. And I'm going to describe just one of the use cases where we're trying to integrate generative AI. It's important to note that digital water sits under the umbrella of HRSD operations. And this is important because digital water could potentially develop tools to help customer service or finance, for example, but that is not why we were created. So we're here to support operations. So if you haven't heard of HRSD, we're a regional utility located in Eastern Virginia. We were established in 1940. We serve 20 counties and cities, covering nearly 5,000 square miles and including 1.9 million people. We have 8 what we call major treatment plants, and then we have 6 smaller plants. We have a total combined capacity of 225 MGD. And as you can see on this map here, HRSD covers almost the whole eastern side of Virginia. I used to be the systems manager for small communities, and that's a lot of the plants that you see up there near the top on what we call the Middle Peninsula. Since that time, we've acquired some small facilities there on the eastern shore that are off to the right. I used to also be the treatment process engineer for one of the major plants down there near the bottom in Suffolk, Virginia. So just a little bit of history about me here. Okay, so let's get into this use case. As you may have noticed, almost all of our plants are discharging into the Chesapeake Bay watershed. And so these plants have very low nutrient limits. And we believe that to meet these limits and do it in a financially responsible way, we need to leverage sensors. And so this way, we expend just enough chemical and energy to meet our limits, and we don't overdo it and waste money. Basically, we don't overfeed chemical. We're not wasting energy on aeration, right? So this would be doing things like ammonia-based aeration control, for example, based on an ammonia probe. But sensors are hard, right? So they get dirty, they fault. So we need to keep a close eye on these sensors to make sure that they don't need cleaning, they don't need calibration, and they're serving their intended purpose. And so what you see here is it's a dashboard that I've built for a Hawk nitrotax sensor, and this sensor is just an example. You know, we have thousands of these things, right? Whether they're nitrotax sensors or they're Hawk ammonia, ISE, ion selective electrode sensors, or they're YSI. You know, the manufacturers vary and the things that they're measuring vary, and that doesn't even include all of the other sensors we have that are flow meters and pressure sensors and level sensors and so on and so forth. So this is just one example of a dashboard for our aeration tank 6 Hawk nitrotax sensor. Like I said, an aeration tank 6 is at our Nansman treatment plant in Suffolk, Virginia. This is the same plant, by the way, where I used to be a treatment process engineer. And in the top left, you can see that we have the recent time series signal from this instrument, recent signals from parallel instruments measuring the same analytes, and then the same signal from the same time last year from the instrument of interest there. So then on the top right, we get, with the bar charts, we get an idea of the sensor's range of measurements, historical, recent, plus parallel sensor ranges and noise. So basically what you can see is over the recent history for this particular instrument, the range is very low, and the noise is also very low for this instrument compared to the same historical measurements and parallel measurements for instruments measuring the same thing in parallel tapes. So we look to the top left where we see the instrument time series signal in red, and there's this really long time where it's sort of flatlined, and we look in the top right and we see, okay, it's not measuring a very large range. There's very little noise coming out of the instrument. It's almost like the instrument signal is flatlined. And then we go down towards the bottom of this dashboard here, and we see how well the instrument is validating against laboratory measurements. Because, once a week we'll go out and we'll grab a sample right next to the instrument, and then we'll run that sample in the lab, and we'll compare it to what the sensor was measuring. And so you can see some of those validation errors in the bottom left chart. And then in the bottom right, it's kind of the same information displayed in bar charts. So what does all this mean for generative AI? Well, the idea would be is that, we have operators and instrument technicians looking at these dashboards, and then maybe they discover a problem, right? Like maybe here they see that, well, the last validation error was pretty big at minus 2.3. It's measuring very low, and it almost looks like this thing is flatline. Well, if there's a problem, what do I do about it? And so there's this link here now where you can click, and it will take you to a custom GPT we've built with OpenAI. And that custom GPT is built on the sensor O&M manuals. It's built on, and I think what the really neat thing is it's built on data and information that we've developed internally, documents that we've developed internally on these sensors. So stuff that's just not available out there on the internet. And you can go onto this custom GPT, and you can click on the link, and you can say, how do I calibrate this instrument? Or I'm observing this kind of fault. What might be the problem? And then it will go and it will give you all kinds of good conversational response. And then based on the response, you can continue to interface with it. Like if you've ever interfaced with ChatGPT, for example, or Claude, it's the same kind of interaction. But again, it's very customized for this purpose. So this GPT has this information for Hawk Nitrotax probes, but it also has information for other sensors that it can draw on too, because there might be some commonalities from sensor to sensor. So you might have information for a YSI ammonia probe and a Hawk ammonia probe, and maybe there are some commonalities between those two different probes that helps you troubleshoot whatever the current problem is that you're working on. So that's it for my use case. Thanks for your time. I appreciate it.
Thanks, Jeff. And with that, we're going to start our Q&A. We are going to do kind of a deep dive questions into the presentations we just had, and then I'm going to reserve the last 5 to 10 minutes to talk about next steps. What can you expect? This is just an interim report out, so about halfway through the project. So at the end, we're going to be talking about what's coming next. What can you expect from us? So my first question is going to go to Gigi, and it's going to be kind of at the beginning when you're giving the application of breast cancer. Do you have a bit more information on that? And if there was any other information outside of vision being used within that AI?
Yeah, I mean, I think inside the article that I read about this is that they did fine tune that large language model with thousands of breast cancer images and results. And then based on the large language model learning that or being fine tuned with that information, it was able to detect at a much earlier, 5 years earlier. And I'm not a medical person, but this is based on this article that I read.
Thanks for the additional context. Our next question is going to go to both Robert and Jeff. We'll start with Robert on the security side of things. And how are you guys addressing that AI can potentially store sensitive water data that your company doesn't probably want shared on the cloud? So how are you handling that security issue?
Yeah, it's a good question. We're currently still working on our data management plan. Part of that is looking at our different data sets and labeling them from highly sensitive, confidential to internal to public. And so we do that as step one. When we do prompts, we can either go the large language model that Gigi had mentioned. We have LLMs that are just made up of internal trusted data, not necessarily public data or internet data. So we can kind of control and look at what we know is reliable. We don't store our data out in the cloud. When in the old days of GPT 3.5, OpenAI used to use our data, our prompts, to train its model. But the new versions, GPT-4 and Copilot and Claude, they no longer use the customer's data to train its model. So unless I misinterpreted this question, we don't store our information out in the cloud. If someone wants to query or if their prompt includes DC water, we've got data sets that are protected, that are not going to be referenced. So again, I'm not the security officer, but that's who I work with. I'm probably leaving off a couple of points, but that's what we're doing right now. We really have a pretty solid plan, and we got some really good people in there that understand security and how to limit the exposure.
Thanks, Robert. Anything to add, Jeff?
Yeah, so some of this information I've used to build the custom GPT that I mentioned in my presentation. It is stored in the cloud, but I don't consider any of that information to be sensitive. So some of this is just documents that we've developed over time on how we like to validate and calibrate sensors, issues that might suggest certain faults that need to be addressed. So we're not talking about any sort of like customer financial data or anything like that, right? Very highly technical stuff that we wouldn't mind sharing with the world. So I guess, the answer is that we try to be very diligent about and mindful of what we're putting out there. And so, yeah, this case I think is just very low risk.
Yeah. And Jeff, just to add to that, and I didn't clarify this well enough. We do use say Amazon Web Service and Azure to store data as well. But these instances are locked down, not open to the public. So that's another way in which most utilities protect their data in the cloud.
Thanks. I think that's really useful information to know. Gigi, I'm going to send this next one to you since you have worked with a lot of different utilities and can maybe provide some high-level thoughts on this. But if the utility is considering undertaking this journey, how important do you think it is to have one or perhaps a few specific project ideas to prime the pump? How important is that?
Okay, well, I do think it's important, but however, what I think is even more important is the training and the sharing of the capabilities of these large language models. So with, a couple of these, webinars or learn for lunch or lunch for learn or something like that, you can get across what the capabilities are. And once everyone understands it, no matter what role that they have in a water utility, they can start thinking about their own role and how they can use some of that capability to enhance it. And so I could almost see, instead of one large project that a utility undergoes, lots of very small ones that are very close to each employee and what they end up doing, for the time that they're at the utility. So it is good to have a few specific projects idea, but I think once people learn about the capabilities, which is what I tried to share earlier today, the floodgates kind of open, like how can we leverage this?
Thanks for that. We're going to start with Jeff and then Robert, if you've got any follow-ups for this next question. So another one on concerns. Are there any concerns about LLMs relying increasingly on AI-generated data, which could lead to the LLM collapsing?
You can go first, Jeff.
Sure. Well, yeah, I mean, I think in this case, again, I'm just speaking just to the HRSD use case. But that's not so much of a concern because that GPT is built on it's built on Hawk data, YSI data, HRSD data. Nothing that I would consider to be AI generated data. So it's a very customized GPT in that way. But I mean, broadly speaking, sure. And I don't know that I'm maybe educated well enough on this issue to speak philosophically about it, right? But yeah, I mean, I understand the point. I don't know, Robert, do you have anything else to add to that?
I do, and I had a slide that talked about where we're making an impact, and I talked about some GPTs, and each of those examples, these were GPTs that were comprised of DC water data, customer consumption data, our CRM, the billing data, but we can get our arms around that data. It's not that large, and it provides a very useful reference for the GPTs, and we can go through, Gigi talked about the neural network and the way it mimics the brain. We come back with the answer, but it's all very manageable. It's not that large that we worry about it breaking, but I guess it could happen for really, really large LLMs, but we're not there.
Gigi, we're going to go to you for our next one, which is what data governance measures should be in place before undertaking generative AI applications? And are there going to be resources that you can share on this?
That's an excellent question, and a question that comes up frequently on our monthly calls and my conversations with utilities. So a few of the utilities that are part of this research project have developed data governance, and they are willing to share that. So in this first report, we should have in the appendix some examples of data governance. However, I think this is a broader subject that really needs to be explored further. One of the roles that could be coming out of this new GenAI world in the water sector is like a chief data officer, because now we don't only have structured data like we're used to. All of our data sets, every piece of information at a water utility now becomes data that could be used for data insights and data analysis. So I think it's very important. I think it's one of the challenges that most of us are facing today. And hopefully we're going to get some leverage on this throughout the next few months in this research project that we'll be sharing.
Thanks, Gigi. Jeff, I've got a few questions for you specifically on the case study that you provided. So the first one is going to be for developing your chat. Did you have to put in all the information manually, or were you able to have the AI extract information from your manuals?
Well, yeah, I'm a little confused by the question. So if you mean by manually, and I know you didn't write this question, but if what's meant by manually is if I went and got the manuals themselves and sort of dragged and dropped them over into the GPT, yes, it was a manual process. I went and found all of the data, both internal and external. I got all of those PDFs, all those manuals, all those emails, and I brought them into, so to speak, the GPT, uploaded them into the GPT to build it. So yeah, I did that.
How long did that whole process take?
I don't know, an hour.
Oh, wow.
Maybe two. Yeah. I mean, it's just a matter of tracking down that information. You know, luckily I maintain a very organized Microsoft Outlook inbox. I have a lot of folders and subfolders. And so it was really just a matter of going to a folder that I have in Outlook and just getting all of that information that I have there.
And your last kind of rapid fire question is going to be, Have you compared the instrument results against your digital twin? And have you used that to help notify you for potential calibration problems?
No, we don't do this yet. I mean, I think this is a good idea. But really, we rely a lot on that validation data that I mentioned. So we take those samples, as I mentioned, the operators do, right next to the sensor, and we run those samples in the lab, and we compare the laboratory measurement to the sensor measurement. But we also rely on a lot on the parallel measurements. I would say that the validation sample and the parallel measurements probably offer a lot more value than the digital twin, but I don't think the digital twin value is zero. There's something there as well, and probably something maybe to even add to the dashboard is something about the digital twin outputs. Of course, the digital twin is not going to capture everything in this case at Nansemond, but in relation to nitrate, nitrite, ammonia, those sorts of things, yes, we could probably add something there. Was there a second part to that question?
You answered it.
Okay.
Gigi, we'll take this one for you. As we start to look into the future, what do you think we should expect timing-wise for widespread adoption of GenAI?
Say that last part again?
For what should we expect timing-wise for the widespread adoption of generative AI?
Yeah, I mean, the whole purpose of this project is really to share as quickly as possible all the experiments that all of these utilities are running and the benefits of it. So hopefully we'll get more and more utilities to embrace it, but there's just so much more to explore. I mean, we're going to look at orchestration of some of these GPTs, how you can concatenate some of them. Agentic systems is going to be a very important research topic that we're going to be looking at. Jeff already talked a little bit about no-code tools such as these GPT. There are low-code, there are no-code. How do we work with that inside water utilities? Also, equity across all digital transformation, across all utilities. Everyone's at a different part of the journey. So how do we accelerate that on all areas? And then some cross-utility collaboration. Once we start getting similar data sets from many utilities, how we could use that to fine-tune large language models. And then the last thing that we're going to be looking at is some training, because training is probably the area that I think we're missing out on in the water sector, and we really need to develop ways that every employee across utilities can get trained on this capabilities.
Thanks, Gigi. I think that goes into part of my next question, which is going to be for David. So this is halfway through the project. Again, you said the final report is going to be submitted in November. What can people expect? What types of deliverables are they going to be seeing? What is AWWA most excited about when it comes to that? Kind of what is the next steps for this project in the next 6 months?
Yeah, so I think so the stuff you can look forward to in that report are, a standard way of language that we'll be using for AI and kind of that direction. A lot of the case studies will provide some of the research that has been done on ways we can use GenAI in a water utility, and also some of the ways to avoid pitfalls of hallucinations and not jumping straight into just using ChatGPT without some sort of security protocols and that sort of thing. Gigi, any other thoughts on that?
No, I think you covered most of it. We're going to have another webinar like this, probably in, like 4 or 5 months. We have our very first in-person workshop, which I think we're going to gain a lot from, because once people are in person with one another, and like I said, we have a large PAC organization plus all the utilities, I think, another report will be coming out, and then the final report will definitely contain all the experiments and all the lessons learned, and hopefully some guidelines for utilities to go to use as they're approaching generative AI.
That's great. And Fadan, I'd love your perspective just on, from WEF's side, the circular water economy. Why is this so important to you?
Thank you. I think it's important because generative AI in general, has been a hot topic for a long time. It's becoming even more so. And it has come up a lot recently because of the silver tsunami, So looking at generative AI, but also AI as a way to address that and train the next generation. So this project will also be helping address that, and we're looking forward to the results from the utilities.
Great. And I think I'm going to kind of have one last question, because we're getting questions about, okay, we've got generative AI now. We know this project is hopefully going to fill in some gaps on that. But what's next? We've heard a GenAI come up a couple times. So from everyone's perspective, this will kind of be our wrap up. What is the next thing we need to be working on? Jeff and Robert, are you all thinking about a GenAI and other applications? Kind of put that out there. Maybe we'll start with Gigi and then just kind of go around.
Agentic AI is very important. These are just, entities that can sit around and automatically do things for you in the background. We've had agents, written by software for, since the 70s, I believe, or 60s. So I don't think that's new, but it's the way that these are created and, with no code or low code capabilities. But I think what's important for the water sector is the next stage is coming, but if the water sector doesn't embrace what we have today, it's going to be much more difficult to embrace the next stage. So hopefully right now we're focused on generative AI and the capabilities and how quickly water utilities can start to adapt to some of these capabilities.
Thanks, Gigi. I think that was a great response.
Agree. Sorry.
No, go ahead, David.
I think, because the water utilities, they have to deal with public health, keeping humans in the loop and keeping people monitoring all of these new tools and technologies. I think it's really critical to try and get GenAI at least understood in the utility and working on it.
I'll take a little different approach at this. Broader picture, we're seeing more players entering into this, more competition, which is great. DeepSeek came out recently with their offering from China. It's amazing how quickly and inexpensively they came up with it. We're seeing new capabilities. Just last week, GPT-4's got a new advanced version of its imagery capability to a much finer degree of being able to interpret and make sense of microbes or bacteria or assets, far greater than what the human eye can do. So it's getting more and more advanced. And I think you're also going to see when our comfort levels get up there are certain tasks that we always say keep a human in the loop, but there are certain tasks that really can be autonomous, okay? The software can make a decision. Again, this is something that wouldn't adversely impact the whole operation, but it can start acting on business rules itself. You also see with the SCADA, for example, not that we want AI to start making changes to what's being tracked, but maybe give the operator some recommendations, looking at trends. I think it's going to become smarter, more useful as a tool, not to replace people, but kind of reshape, reframe what people do and the tools they use. It's a real exciting journey, and it's what I know now. Probably it'll be changed a lot in 6 months because it's a struggle keeping up with the technology. It really is. It's exciting times.
We're excited to be on this journey with you, Robert. And Jeff, anything last to add?
No, just that I agree with Robert. I think it's a lot more autonomous facility operation. Also too, GenAI it's being leveraged in robotics right now. You can go online and you can watch a lot of videos about humanoid robots that are leveraging GenAI, drone technology. I think that these things are going to sort of work their way into the water sector here as time goes on.
Yeah, I got one more thing that I can add. Jeff sparked my interest when he talked about robotics. So with generative AI, you could also see advances in material science and how that's going to change, pipes and valves and other assets that we use in the water section. It's also going to change, like he said, robotics. Science in general is going to advance at a much faster rate. So we are in the science build industry with the water sector. So we can see advances at all sides of the equation for a water utility. So I'm excited about that as well.
So my big takeaway from this is a really exciting time for the water sector, but there's a lot of work that we still need to do. And so I'm excited this is only halfway through our project. So stick around with us as we have, hopefully our first report will come out late summer. That's our goal. And then in the winter, we'll have our final report. We'll have another webcast. I want to thank our speakers. This has been fantastic. I want to thank our audience for sticking with us through the end. You can have download the slides. Our webcast will be available in the very near future. You can get access to our project page, which is where all of our deliverables will be published. And just lastly, please stick around the very end for a quick survey to tell us what topics you're interested in learning more about, and just feedback on this survey or on this webcast. So thank you all. Hope you have a great rest of your day.